This is section 4.5b, and it's an extension of section 4.5. It's on page 251. I would definitely have your book open to that page. And this section is called Solving Equations Graphically. I'm going to move this icon off of here. Let's first of all say or mention that this section I'm going to put under the category of extra credit. I'm going to do that for the following reason. This section is actually written as one of the state of Michigan standards. However, I would say that this is probably one of the most inefficient ways of solving an equation. I guess I would think that maybe they made it a standard is just to give you a background knowledge of how finding an x-intercept would relate to finding an equation, but to be honest with you, I can't remember one time in all my mathematical schooling, that includes college, getting my mathematical major, ever solving an equation by using this method. So I think it's probably more just to help you relate on how an x-intercept would also be the solution to an equation. Now, to get the extra credit, this is what you're going to need to do. It's not going to just be, well, I did it and I get extra credit. To get the extra credit, watch this video. Please attempt the problems on page 252, 1 to 9. And then you're going to have to pass a quiz over this material. I would give you the quiz before or after school on your time. I'd give you 2 attempts to do this by the due date that I have listed on my Skyward page that you would see this video attached to. And I would give you 5 extra credit points if you passed this quiz on this material, and those points would go in that 30% section quiz category grade. Okay, so again, this extra credit is not predicated on, well, I just did it. It's you have to show me you know it. All right? So let's walk through how this would work. Okay? And actually, I'm going to turn these layers off so I can talk about them one at a time. Look at the key concept box on page 251. Solving an equation graphically is a 3-step process, and they outline it in that box. So I'm going to walk through each of those points. First of all, you need to write your equation in ax plus b equals 0 form. We'll walk through examples of that on this video. Next, you're going to replace 0 with y, which would make the equation in slope-intercept form. Finally, you'd graph that equation and you'd locate the x-intercept. The x-intercept is the solution to the problem. So let's actually try one. Okay, 4x minus 9 equals negative 6. So the first step, when I look here, the first step is to write the equation, so it's in this form. So in order to do that, I'm going to have to get negative 6 and move it over to the left side of the equation, so I'm going to do that here. I'm going to add 6 to each side of the equation, and when I do that, I'm going to get 4x minus 3 equals 0. Okay, that satisfies step 1 of these instructions. Step 2, replace 0 with y. So when I replace 0 with y, I would end up with 4x minus 3 equals y. And you notice this is now slope-intercept form. Slope-intercept form is what you learned in section 4.5. All right, the slope of this line is 4, and the y-intercept, don't forget the negative sign, the y-intercept of this line is negative 3. So now I need to go ahead and graph this. I'll do that now. 4x minus 3 equals y. So let me write that actually up here. My slope is 4 and my y-intercept's negative 3. So I'm going to go to negative 3 on my graph, plot that point. I'm going to apply my slope of 4, which means I'm rising 4 and running 1. I'm rising 4 and running 1, and I'll do that one more time. And as you see, when I do that, I ought to have a straight line of points, which it looks like I do. I'll take my ruler. I'm going to draw a line through these points. Going to draw a line through these points. And in this case, my x-intercept is going to give me the solution to this equation. Now, this is one of the weaknesses of this method, which is why I don't really understand why the state would make it a standard, but they did. My x-intercept is where the line crosses the x-axis. On this, it's kind of hard to tell. It looks to me like the x-intercept for this problem is 3/4. It looks to me like the x-intercept is 3/4. And we'll check that real quick. So I think it's 3/4 is the x-intercept. This is the point. Looks like 3/4, 0. Let's go back and see if that would actually work or if that's a solution. So let's try it. If I take my calculator and I replace x with 3/4, okay, let's see if that would work. We can use our calculator. So we're going to take 4 times 3/4 minus 9, and we want to see, does that equal -6? Well, if I take 4 times 3/4, I get 3, and 3 minus 9, yes, does indeed equal -6. So that would mean 3/4 was the solution, and this is how I solved that problem graphically. All right? That's what you have to do to solve a problem graphically, that 3-step process. Maybe we'll just do one more real quick. We'll do one of these problems in the book just so you see one more look at that. So let's look at number 1 in the book on page 252. They want you to solve the equation graphically and then check it algebraically. Well, okay, let's do both of those. So let's solve it graphically first. 6x plus 5 equals -7. Remember, step 1 is to rewrite this equation so that it's in the form ax plus b equals 0. So I'm going to do that first. So I will do that first right now. I got to take away, I'm sorry, time out. I wrote the problem down wrong. 6x plus 5 equals -7. I forgot the negative sign. Okay, so let's rewrite this so that it's in the form ax plus b equals 0. I'm going to add 7 to each side, which means 6x plus 12 equals 0. That's step 1. Step 2, replace 0 with y, which I'm going to do right now. So I get 6x plus 12 equals y. Now I have to graph this. There is my slope. My slope is 6. My y-intercept right now is 12. Shouldn't write y. I should put y-intercept equals 12. So let's go ahead and graph that. 12. It's almost running off my screen. It's about here. And since my slope is 6 and I can't rise 6 and run 1 and fit it on here, I'll go down 6 and left 1. I'll go down 6 and left 1. And I'll do that one more time. And I'm going to take my ruler out now and draw a line through these points. And you notice when we draw a line through these points that we cross the x-axis at -2. It looks like the x-intercept in this problem, better spell that right, sorry, x-intercept is -2. So that would be -2, 0. Let's check and see if that works. So if I go back to my original problem, which is here, and I plug in -2 for x, 6 times -2 gives me -12, and when I add 5, I do indeed get -7, so I check it that way. Let's check it algebraically like the instructions say. 6x plus 5 equals -7. To check it algebraically, let's solve. Let's take away 5, which would give us 6x equals -12. Let's divide by 6, and you see when we check it algebraically, we're getting the same result. We're getting -2, where when I graph it, I'm still getting -2. So that's how we solve an equation graphically. Again, I don't think that's the best method of doing it. The only reason I could think of this being a state standard is just to give you the concept that the x-intercept is also going to be the solution to your equation. Okay, so I'm going to stop the video there. Again, this is optional. You do not have to watch this, or you don't have to even do it, but I guess if you watch the video, you want to do it. Try the homework. if you take the quiz, I'll give you 2 shots to pass it. You have to pass the quiz to get the extra credit, all right?